Assalamualaikum warahmatullahi kembali ke chapter 4 bahagian kedua. Hopefully we can finish within one video. So for the last video, we start at this thermocouple. So we continue to this slide for the second part of the video. So a thermocouple are still an instrument to measure a sensor. So thermocouple is made from bonding of two different metal in the form of two symmetrical junction, with one junction is fixed temperature as a reference point. So as you see the figure below this figure, so you can see um, the illustration of the thermocouple. So this one, output voltage in the order of 10 of millivolts usually fit into a FET amplifier. This is the thermocouple. It consists of two wire A and wire B. So this is voltmeter, T1, T2, hot junction and cold junction. So this is the detail of the moving electrons moving in the wire, so that we can measure the temperature. When a pair of wires made of different metals are joined together at one end, a temperature difference between this end and the other end of the wires produce a voltage between the wires. Okay, so this is the principal working of the thermocouple. So this phenomenon is called as the seeback effect. So this form the basis of thermocouple. So this is the basis of thermocouple. Temperature being measured. This is the sensing junction. The difference between temperature difference between A and B produce a voltage between the wires. So this is the output voltage. So depends on material wire. So we get the temperature difference. It consists of a pair of conductor. This is the construction of thermocouple. Consists of a pair of conductor from different type of materials, covering wide range of temperature -10 to 70 degrees until 2700 degrees Celsius. Both conductors are connected on one side to give a closed loop where the temperature is measured. This side is called the hot junction or sensing junction. The sensing junction is placed in or on the material being tested. So the sensing junction is touched to the material being censored, being tested. The other side, where both conductors are open, is called a cold junction. It is connected to the voltage measuring equipment. So this side is maintained in hot, and cold junction give the magnitude of the voltage. So that is the construction of the thermocouple. So this is the physical outlook of the thermocouple. Thermocouple in practice. We have a metal A, we have a metal B, wire, protective outer shell. Okay, so this is the part that touch with the tested material. Okay, so this is wire is connected to the meter. That thermocouple in practice. So this is a voltage amplifier, metal 1 and metal 2. So temperature to be measured. This is the material or object to be measured. So this is the reference temperature. So this between these two difference of temperature, it produces a certain output voltage. So this is the example of the thermocouple, US patent 1977. One is protective metal shell, dark gray stainless steel. or an alarm. 2. First wire, metal A. 3. Second wire, metal B. 4. Insulation crushed and compacted manual outside. 5. Cement to hold insulation. And 6. Electrical insulation. So this is the uh, one type of the thermocouple which is patented in United States 1977. So if you work in industry later on, you may see this thermocouple, or you may use this thermocouple in a certain task to measure temperature. Okay, so this is the thermocouple in practice in slide. Example of thermocouples. See, this is the type of thermocouple B, C, E, J, T. So the name of material used for the thermocouple, useful application range. So the if you use different material of the thermocouple, it has it has different characteristic, especially for to measure the range of the temperature. Okay, if you look at here, thermocouple type B, material platinum, 30% platinum, 6% positive and negative, 2,500 until 3,100 Fahrenheit for the positive, and 1,370 up until 1,700 Celsius for negative. So this is the range of temperature for the thermocouple type B. Thermal EMFS for some common thermocouple material. So this is the common thermocouple material. So material, the temperature, the thermal EMFS for the thermocouple material. Electromagnetic frequencies. So the higher of the EMS in millivolts, the higher the temperature, but depends to the type of material. You can see the type of material, CRCN, see the type of material, RE, RE tungsten. Coopers, sensitivity 41 microvolt, operating range negative 200 degrees Celsius to 1005. So if this is the material coopers, chrome and aluminum, sensitivity 41 microvolt, operating range negative. It depends to the application. Some application you want very detailed measurement of the temperature, then you need to have a very high sensitivity. Okay, but some measurement maybe you can tolerate with the sensitivity, so you can use other material. Okay, the more sensitive your thermocouple, the material maybe it is expensive. Mm. So this is the other type of thermocouple: insulated, uninsulated. Insulated means they cover with some material, probe assembly, thermocouple well protection. So this is the how the thermocouple works. Okay, so this is the equation. The difference um, the difference of A and B uh, produce the voltage. So to calculate the voltage, so this is the formula equation. V naught equals to C, constant of the thermocouple material. T1 minus T2. T1 is the temperature of hot junction. T2 is the temperature of cold junction or reference junction. Plus K multiplied by T1 power of 2 minus T2 power of 2. Compensation circuit. Okay, example of placing the second junction in an ice bath to provide cold junction compensation. So this is the example circuit that show a thermistor used to provide cold junction compensation. This is type of compensation is called software compensation because the reference voltage must be calculated with hot junction voltage to get accurate reading. Okay, compensation circuit. So why we need to do the compensation? Compensation. The second junction can be controlled so that it produces 0 volt. So this is accomplished by forcing its temperature to 32 degree Fahrenheit or 0 degree Celsius. Okay, in the year 1800s, this was accomplished by placing the junction into the ice bath. So this is the how the thermocouple compensation for the of the thermocouple. So the junction became known as the cold junction. Modern thermocouple today circuit can accomplish the same junction with an electronic compensation circuit called cold junction compensation. So we just use this cold junction compensation. This is the old the old way to do the compensation. This is a new. We just use this. We have a circuit. They call it compensation circuit. Provides the equivalent voltage produced by the junction in the ice bath so that the actual voltage produced by the junction that is measuring the amount of heat can determine the temperature accurately. This is an example. Okay. You just look at the example, try by yourself first, and I will come back with this another video for the example. So summary for the thermocouple is the most versatile temperature transducer. RTD is the most stable. Thermistor is sensitive. Out of three major categories of sensor, the thermistor exhibit largest parameter change with. So, so this is the comparison of the three types of the uh, instrument temperature, thermistor, RTD, and also thermocouple. Okay. Right. Next is calibration. The instrument we need to do a calibration after a certain year, for example, or after a few or several usage. We need to do the calibration because maybe some of the measurement um, has an error, so we need to do a calibration to ensure that um, the instrument is no errors. Yeah, something like that. Okay. What is the calibration? The process of determining the performance parameters of an instrument or system by comparing with measurement standards. Assures the device system or system will produce result which meet or exceed some defined criteria with a specified degree of confidence. All instruments suffer drift in their characteristic, and the rate depends on environmental conditions, frequency of their use. Errors due to instrument being out of calibration can usually be rectified by increasing the frequency of recalibration. So calibration can be called for. Okay, if you have a new instrument, maybe you need also do a calibration because the new instrument maybe it's never used quite a long time, so we need to do a calibration. A specified time period is elapsed. Okay, a specified operating hours has elapsed. The instruments has had a shock or vibration. Whenever a vibration appear questionable, then we need to do a calibration. Comparing the output of the instrument under test against the instrument of known accuracy when the same input is applied to both instruments. So this is how we do the calibration. Compare the output of the instrument and then when the same input is applied to both instruments. How to do the calibration? Often regarded to include adjusting the output or indication on a measurement instrument. to agree with value of the applied standard within a specified accuracy. Example, a thermometer could be calibrated so the error of indication or the correction is determined and adjusted so that it shows the true temperature in Celsius at specific points on the scale. Okay. The three important calibration measurement concept: precision and accuracy. Precision, the minimum discernible change in the parameter being measured. Accuracy, the actual amount of error that exists in a calibration. So precision and accuracy is two important calibration measurement. All measurement process used for calibration are subject to various sources of error. It is common practice to classify them as random or systematic error. So you can go back to the previous chapter to see the random error and systematic error. So this is the example of flowchart for calibration. Classification, customer, technician in charge, and so on, worker in calibration. Request for and contract of calibration, technician in charge, check if there is any calibration, and so on, worker, still stick label and object of calibration, calibration contract fill in. So this is the flowchart. Prepare, no, issue calibration report, text invoice, return object of calibration, follow up service. Okay. So this is the flowchart of the calibration. An instrument is required to measure some quantity and an accuracy of plus minus 2% is acceptable, then a certain amount of performance degradation can be allowed if its inaccuracy really of the recalibration is plus minus 1%. So if the instrument is only can tolerate the negative plus minus 2%, then a certain amount of performance degradation can be allowed if uh, only plus minus 1%. Masih boleh digunakan kalau performance degradation tu plus minus 1%. Factors affect calibration process. Instrument used for calibration. So this is a greater inherent accuracy only used for calibration purpose. Repetitive measurement at prescribed interval. Mechanical wear and tear. Dirt, dust, fume, chemical temperature change. So this is the factor that affect calibration process. Inherent, repetitive measurement. Kemudian ada mechanical wear and tear, dirt, dust, temperature change in operating environment. 2. A proper course of action conducted. Deep knowledge in instrument calibration. It's not easy to do the calibration. It needs to have a person who has a deep knowledge in measurement, error, interval recording, environment, conditioning, etc. So the other factor affect calibration process, authorized person in handling suitable environment. Okay, you cannot do a calibration in a common place. It must be very specific, like in laboratory. Level of accuracy that should be considered. Standards, facilities of requirement in the whole of calibration. Measurement of calibration procedures in all operations. Third, control of calibration environment, managed and executed in a professional manner. Okay, so that's all the factors that affect of calibration. There are three factors. One, instrument use for calibration, proper course of action, and the last one, control of calibration and environment. Quality and traceability, to improve the quality of the calibration and the results accepted by outside organization. It is desirable for the calibration and subsequent measurement to be traceable to the internationally defined measurement unit. So the traceable of the calibration system is referred directly or indirectly to the National Reference Standard, NIST, and supported by calibration certificate. So this is the quality and traceability. National Standard Organization, Instrument Calibration Standard, National Standard Organization, Standard Laboratory, Company Instrument Laboratory, Process Instrument. So it is not an easy task to do calibration. It must follow a standard. Like in Malaysia, if you want to do a calibration, proper calibration, you need to go to like authorized authorized center, for example. Some of equipment have to do a calibration and follow a standard. Uh, for example, like uh, weighing instrument, penimbang kat kedai-kedai tu. After certain time, certain years, for example, that weighing tu need to go to send to the uh, to calibrate, and you cannot calibrate by yourself. You need to have, you need to go to send to the authorized calibration center, kan, then get the certificate. If there is enforcement to check your weighing tu, whether you do a weighing, you calibrate a weighing or not, then you can show uh, the certificate. Okay, if you don't have that certificate, then you will be fined lah, kan, summoned by the local authority. Because weighing ni is very sensitive. Some of the hawker kedai-kedai tu, sometimes they adjust by themselves, kan. So it's need to do the calibration in order to get the precise or accurate reading. Working standard procedure will contain at least following information: identification, calibration, measurement, use limitation, date of calibration, authority under which authority under which the certificate is issued. Okay, so this is the quality and traceability ISO 900 and 9000 set of standard. This is the standard. This standard has been developed and used and recognized internationally. So you don't have to worry about the standard commission for the standard. People must be understand what they need. Successful completion of training course should be marked by the award of qualification certificate. So this is the an example of calibration process. Arrival, calibration, testing, okay, non-conformity customer, contact customer, for repair, okay, shipping, kalau rosak, disposal. Standard format for the recording of calibration results should be defined in the paper proper documentation. So the documentation must also define the manner in which calibration results are to be recorded on the instrument themselves. A separate record must be kept for every instrument present in the workplace. Calibration record should include the following document: details of the instrument, the required calibration frequency, so how many times the instrument need to calibrate, the date of each calibration that have been done, the calibration results on each occasion. This is the example of this example. Two others item must be also covered: the traceability. Training procedures must also be documented, specifying the particular training course to be attended by various personnel, refresher, and etc. That's all for chapter 4. So for this chapter 4, we did cover all uh, process, all measuring and devices, focusing on sensor and transducer. We also, on the last part of this chapter, uh, we also discuss about the uh, calibration, right? All the instrument need to do the calibration in order to get the accurate measurement or reading. Okay, so that's all. If you have any question, please do contact me. I will prepare the video for all example of part 4 very soon, so that you can understand the calculation or the circuit in this chapter 4. Thank you very much. See you in See you in next. See you in next video. Thank you. See you again. Bye bye.